So welcome to another part of telecommunication, and this one is space communication. So speaking about space communication simply is a process of receiving, sending and processing information through the space. And before we go further into space communication, let us first define the term ionosphere. So saying ionosphere means is a layer of the Earth's atmosphere which contain high concentration of free ions and electron. So it lies above the Earth's surface. It lies above the mesosphere, and it extends about 8 to 1,000 kilometers above the Earth's surface. So this one is ionosphere. It's just a region where you're going to find high concentration of ions and free electrons. It's about 80 to 1,000 kilometers above the Earth's surface. So let us see the layers of ionosphere. The most important layers of ionosphere we're going to discuss here, there are 3 layers. We have the D layer, we have the E layer, and we have the F layer. So let us start with the D layer. So speaking about the D region or the D layer, this one is the lowest, which is found about 60 to 70 kilometers above the Earth's surface, extending about 90 kilometers upward. So this one is the lowest region, and this region is responsible for absorbing the radio waves during the day. So the region is the lowest one, 60 to 70 kilometers above the ground, and it may extend up to 90 kilometers above. We call it sometimes the region of ionization below 100 kilometers. So this one, it can't extend above 100 kilometers from the Earth's surface, but below 100 kilometers, ionization do take place at this region. So another layer is a E layer. So simply the E layer is a middle layer which is 90 to 150 kilometers above the surface of the Earth. This one is a middle layer. It is found between the D layer and the F layer. So ionization in this layer is always due to soft X-ray. So ionization can take place to this region, but takes place in the presence of soft X-ray. This one is a E layer. So the last layer is the F region or F layer. This one is the highest layer in the ionosphere at altitude above 160 kilometers. So this layer has a high concentration of free ions and free electron. So among the 3 layers, among the D layer, E layer and F layer, the F layer is a layer which contains high concentration of free ions and free electrons. So let me give you a quiz. I think when you are listening to radio, you can hear the information during the night than during the day. So the question is, why is there poor reception of radio waves at the day time? Remember I told you we have 3 layers. We have the D layer, we have the E layer, we have the F layer. So during the day, the D layer is present, but during the night, there is no D layer. There is only E layer and F layer. So presence of D layer during the day is responsible for the absorption of radio waves during the day. That's why when you are listening to the radio during the day, it can be clear than when you compare listening to a radio during the night. Some people do say during the night, the internet speed is always highest. You know, people do say maybe it's because the people who are using internet at the night, they are few compared during the day. But this one can also play a role. This can also be the reason, because presence of D layer during the day, it is responsible for absorbing the electromagnetic waves. That's why there is always poor connection poor reception of waves during the day because of the presence of the D layer. But at the night, we have no D layer. So guess what? There's good connection, good reception, and the radio waves can be received in a good way. So that one can be the answer due to absorption of waves by the iron in the D layer. During the day, there is a D layer, so it absorbs the waves. During the night, so it is not D layer, so no absorption of the waves. That's why transmission, reception of signals during the night is more efficient compared to receiving information during the day. Okay, so the ionosphere, it has advantages. Presence of the ionosphere, it has a benefit to organisms and the human being. So the first advantage of the ionosphere is that it prevents the microorganism from the effect of the ultraviolet rays. So the UV rays are very dangerous. They can harm the microorganisms. They can kill the microorganism. So presence of the ionosphere, it helps to absorb the UV rays so that they cannot be harmful to the organism. That is the first important. But also, the UV rays is responsible for causing skin cancer to the human being. So the skin cancer can be caused by excessive amount of the UV radiations. Now, presence of the ionosphere, it helps in absorbing the excess amount of the UV radiations. So it prevents us from getting skin cancer. Now, let us see the radio communication. So speaking about radio communication is a wireless communication which involves the radiation of radio waves or audio signals by the transmitting station over a large distance. So simply, a radio communication is a wireless communication. It involves radiating the radio waves or audio signals by the transmitting station over the large distance. And these signals, when they are radiated, they are being received by the receiver to the destination where they are being transmitted. So let us define the term radio waves, because we have seen radio communication involves the radiation of radio waves. So what is a radio wave? So a radio wave, we say that is a type of electromagnetic radiation which has a longest wavelength in the electromagnetic spectrum. So in the electromagnetic spectrum, radio waves are the one with the longest wavelength, about 300 gigahertz. This one is a radio waves. Let us now see the ways in which we can transmit radio waves. There are 3 ways. The first one is ground or surface wave propagation, and you have the second one, we call it skywave propagation, and the last one is space wave propagation. So let us now see the ground wave propagation. So speaking about ground wave propagation, this means the radio waves are being transmitted and propagated by one transmitter and another receiver on the Earth's surface. So we have the transmitter and we have the receiver, which are both installed on the Earth's surface. So let us see the diagram here. You can see here we have the transmitter and we have the receiver. Both transmitter and the receiver are on the Earth's surface. So information from the transmitter, they propagate to the receiver, which is also installed on the Earth's surface. So you can see tunayo hapa surface ya dunia, transmitter na receiver zote zipo kwenye surface ya dunia. So information from this transmitter, they are being sent, they propagate to the receiver on the Earth's surface. So this one is a ground wave propagation. Let us see the advantage of ground wave propagation. So the first advantage we say is that the ground wave propagation has excellent reliability. So the availability of the information is present all the time. So it has excellent reliability. And the second advantage is that reception is not affected by changing atmospheric conditions. So whenever there is rain, there is wind, the information transmission is not affected. That is the second advantage. So the third advantage of ground wave propagation is that when there is high transmitting power, with regard of enough transmission power, ground wave propagation can be maintained at any place in the world. That is another advantage of ground wave propagation. Let us now see the disadvantage of ground wave propagation. The first disadvantage is that ground wave propagation requires high transmitting power. So sometimes to achieve that high transmitting power is very difficult, especially in ground wave propagation. So the next disadvantage is that ground wave propagation, it involves ground losses, which is increase rapidly with the increase in the frequency of the signal. So whenever the signal they have high frequency, the ground losses becomes very high. So when there is ground losses, the transmission of information starts to lose its efficiency. So there will be poor transmission of information. That is the next disadvantage of ground wave propagation. Let us now see the skywave propagation. So speaking about the skywave propagation means that radio waves from the transmitting antenna, they reach the receiving antenna after being reflected by the ionosphere. So we are going to have a receiver and a transmitter. So information from the transmitter, before reaching the receiver, they first reach the ionosphere and they are being reflected to the receiver. So you can see to this diagram, we have the information coming from the transmitter, they are being sent to the ionosphere, then reflected back to the receiver. This one is called the skywave propagation. So let us now see the space wave propagation. So speaking about space wave propagation means that the information or the signals, they travel in a straight line directly from the transmitter to the receiver. So we have the transmitter and also we have the receiver. So information from the transmitter, they directly reach the receiver in a straight line. So you can see here, we have the transmitter, but also we have the receiver. So information from the transmitter, they travel directly to the receiver. You can also see there is information which they reach the surface of the Earth. They are being reflected from the Earth's surface to the receiver. But the most important thing here to know is that between the transmitter and the receiver, there is a direct transmission of signals from the transmitter to the receiver. We call it a direct wave transmission. So here the information are being transmitted in a direct fashion from the transmitter to the receiver. This one is a space wave propagation. Let us now see about satellite communication. So speaking about satellite communication, this means there is a spacecraft which is orbiting around the Earth, which carries a body or an equipment which is capable of receiving and transmitting information from one point on the Earth to another point on the Earth. So this one is a satellite. You can see here. This point sends information to the satellite. The satellite receives the information and then it carries an equipment. This equipment on the satellite, it also transmits the information to another point on the Earth. So there are 2 points. Both points are on the ground stations. Both points are on the surface of the Earth. We call them ground stations. So this station here will send an uplink information going to the satellite, and the satellite will send information to another ground station. We call it the downlink. Let us see the advantage of satellite communication. So the first advantage of satellite communication, we say that one station can cover a large area on the Earth. You can find that you have on a single satellite, and it can cover up more and more countries. A single satellite. We say that one satellite can cover up to an area of 42,400, which is almost 42% of the whole globe. So in order to cover the whole globe, we would just require at least 3 satellites. So that one is an advantage of satellite communication. One satellite or one station can cover a large area on the Earth. So another advantage of using satellite, we say that it is very reliable. So by using satellite communication can be achieved at any moment. All the time you can achieve communication because it is more efficient way of communication. So another important of satellite communication, we say that communication cost is independent of the distance between 2 points on the Earth. So sending information between one point and to another point, so it is independent of the distance between the 2 points. So the destination of transmission of signals is independent of the cost. So sending information in 10 km and sending information with a destination of 100 km, the cost is always the same. That is one of the advantages. So another advantage of using satellite communication is that it is more accurate for search and navigation. So this one involves looking for different pages in the internet, looking for specific information on the internet. This one is a more accurate way of searching and navigation. Let us see the disadvantage of satellite communication. And one among the disadvantage of satellite communication, we say that cost of placing the satellite in a geostationary orbit is very high. A satellite can only be placed in a geostationary satellite. So placing a single satellite to a geostationary orbit, it can cost around 10 million US dollars or at around 400 million US dollars. So you can see how it is more costful placing a single satellite. That's why most of the telecommunication engineers, they can develop a satellite, but placing it to a geostationary orbit becomes more difficult because of the high amount of money required to place a single satellite. So another disadvantage of satellite communication, we say that in telephone conversation, the response is not instant, but you can observe there is a delay of receiving information. So there is a delay about some seconds before information they can be received by a receiver. That's why it's not more accurate in telephone conversation. And another disadvantage of satellite communications, we say that signal from satellite are open at all satellite communication. Hence, there is low security. Security and privacy is not guaranteed using the satellite communication. That's why some of the hackers, they can easily access your information when it's through satellite communication. And the lasting disadvantage of satellite communication is that satellite equipment can be subjected to environmental condition. So the satellite equipment can be subjected to extreme environmental conditions such as temperature, the radiation. Both they can affect the satellite equipment. So that's why in a bad weather condition, satellite communication is always poor because its equipment can easily be affected by environmental change. So let us now see the optical communication. So in optical communication, there is a light beam that is acting as a carrier of information from one place to another, from one point to another point. But the information is always carried at a high rate, at a fastest rate compared to radio waves and microwave. So simply there is a light beam carrying information from one point to another point. This one is optical communication. So transmission medium of optical communication is not air. Why not air? It's because the light beam, if it could transfer through air, it could be absorbed, because in air or in free space there are a lot of options for absorption of a light wave. That's why a light beam, it carries information, but its medium is not air because of the fear of absorption of a light beam. But also there is a fear of interference. So if it could travel through air, there could be interference with other light sources. That's why transmission medium of light beam is not air. So this one is an optical communication system. So there is a signal entering to an optical fiber. This optical fiber, it carries an light beam. So you can see this one. This one is a light beam carrying a signal from the transmitter to the receiver. This one is an optical fiber. Within the fiber, there is an optical beam. There is a light beam. This beam carries information from the transmitter to the receiver. This one is an optical communication. So let us see the types of optical fibers. We have two types of optical fibers, and the first type we say is a multimodal fiber or fiber, multimodal fiber. And this multimodal fiber, we say that it has large core, allowing multiple passes through the fiber. So the core of the multimodal fiber is large, and being large, it allows multiple passes of beam to pass through. And another type of optical fiber is a single model fiber or SM fiber. So a single model fiber or a single mode fiber, it has one pass through a much small core. So there is only a single pass in a single mode fiber. So this one is a multi-modal fiber allowing multiple passes. You can see here there are multiple passes traveling through the optical fiber. This one is a multi-mode fiber. So this one is a single mode fiber. It has only a single pass. So we have two types of optical fibers. We have the multi-mode fiber and you have a single mode fiber. Let us now see the advantage of using optical fibers over copper cable. And the first advantage, we say that the optical fibers have high information carrying capacity. So optical fibers can carry high amount of information comparing to the copper cables. But another advantage of using optical fibers over copper cable is that it is free from noise. Compared to the copper cable, can be easily interfered by electrical noise, because we say that a copper has got ability to transmit electricity. Copper is a conductor. So using a copper cable, there is a high chance of having interference from the electricity. So using an optical fiber, it will free you from noise reception. So another advantage of optical fiber over copper cables is greater distance of operation without using regenerators. So when you are using a copper cable, you would require a signal booster at certain long distance. But using an optical fiber, you don't require a booster. When I say a booster, means at a certain point you need a device which is going to increase the transmission rate of the signals. But using an optical fiber, you don't need booster. You don't need to boost the transmission of signals. It can be used at a greater distance without using boosters compared to the copper cable. So another advantage of using optical fiber over copper cable, we say that it is lighter, smaller, and easier to handle. So the copper cable are very large and cumbersome, and sometimes it is very difficult to handle them. but when you are using an optical fiber, it is very light, ni nyepesi sana, na it's very small, ni ndogo kiasi kwamba unaweza kubeba na kuhandle very easily. Another advantage of using optical fibers over copper cables, it offers greater security and privacy to the user. So there is a greater security in using optical fibers compared to the copper cables. Information or signals when passing through a copper cable can be easily stolen, but there is a greater security and assurance of privacy when you're using an optical fiber. So this one is the end of telecommunication, and the next part I will be solving different calculation questions and different scenario questions, different conceptual problems regarding to the topic of telecommunication. So